Good morning. Today's lesson is 5.4, which is solving exponential and logarithmic functions or equations. So the first thing that we're going to do is solve some exponential equations. So what you have to do first is isolate the exponential. So we have to get rid of this 9. So what we're going to do is we're going to divide both sides by 9. And that's going to leave me with 10 to the 2x equals 12 over 9. And you could reduce that if you want. Now, anytime to solve an exponential, you have to use a logarithm. So you're really changing this into logarithmic form. So the base of your exponent is also the base of your log. So you're going to write log base 10 of, well, 12 over 9 actually reduces to 4/3. So we can write 4/3 equals 2x. So we're solving for x. So we're going to divide both sides by 2. So we would have x equals log. Remember that if it's base 10, you don't actually have to write the 10. So I'm going to leave that off this time. So we'd have log of 3/4 over 2. This would be what is called our exact solution. To find our approximate solution, you're going to type that in the calculator. Now, the next one, the base is e. Whenever you have a base of e, you're going to change it to a natural log. So it's actually a log base e, but log base e is equivalent to ln. So we'd say log base e of 19 equals 2x. But like I said, log base e is really ln. So I'd have ln of 19 equals 2x. Divide both sides by 2. We get x equals the ln of 19 over 2. Again, this is an exact solution. If they want an approximate, you would type that in the calculator and then be sure to round to however many decimal places they're requesting. So if they said round to the nearest hundredth, round to 2 decimal places, round to the nearest thousandth, round to 3 decimal places. So here are some more exponentials. Again, what you have to do again is you have to isolate the exponential part. So I'm going to subtract 7 from both sides. So I'd have -6 e to the x equals -6. Divide both sides by -6. I get e to the x equals 1. Again, when you have e, it's really ln. So we'd have the ln of 1 equals x. If you type that in the calculator, you can see that x is 0 because e to the 0 is going to give me 1. You can always plug your answers back in and check as well. On the next one, we're going to add 7 to both sides. So we'd have 6 to the 7x minus 2 power equals 16. Divide both sides then by 5. Again, we're trying to get that exponential part by itself. And then we have to change it to a log. Well, again, the base of your log is the same as the base of the exponent. So it'd be log base 6 of 16 over 5 equals 7x minus 2. We have to solve for x. So we're going to add 2 to the other side. We'd have log base 6 of 16 over 5 plus 2 equals 7x. Divide both sides by 7. And we would have x equals log base 6 of 16 over 5 plus 2 over 7. Again, this is an exact solution. Plug it in your calculator to get the approximate solution. The next problems, these are a little harder because on these, the bases are not the same. So we have to pick one of them to go off of. And a lot of times I pick the one that's a little more complicated. So the exponent here is an x minus 1, which is a little more complicated than just an x. So what I'm going to do is I'm actually going to take the log base 7 of both sides. So I'm going to say log base 7 of 6 to the x equals log base 7 of 7 to the x minus 1. Now, what that allows me to do, the properties of exponents say I can, or logs say I can move that exponent to the front. So this is really x times log base 7 of 6 equals, well, again, we can move our exponent to the front, but then we would have log base 7 of 7. Well, we had a property in a previous section that said log base 7 of 7 is really just 1. So we don't necessarily need that there. That's equivalent to 1. So what we need to do then, we would have x times log base 7 of 6 equals x minus 1. Get everything that has an x on it on one side. So I'm going to say x times log base 7 of 6 minus x equals a negative 1. Well, in order to be able to solve for an x, you can only have one of them. So what we're going to do is factor out an x on this side. So we're left with log base 7 of 6 minus 1 equals negative 1. The next thing we're going to do is solve for x by dividing both sides by log base 7 of 6 minus 1. And you get x equals a negative 1 over log base 7 of 6 minus 1. Again, that would be an exact solution. To get your approximate, you're going to plug that value in the calculator and round to the correct number of decimal places. If you're looking at the next one, again, pick the one that has the harder exponent or the most complicated exponent. So we're going to use 6 here. So I'm going to say log base 6 of 5 to the x equals log base 6 of 6 to the x squared. Again, that allows me to move it out front. So I'd have x, then I would have log base 6 of 5 equals, again, move our exponent out front, but log base 6 of 6 is just 1. Now, again, we're going to move everything to one side. I'm going to go this direction this time. So I'd have x squared minus x log base 6 of 5. Now to solve this, again, we're going to factor out what they have in common, which they have an x, and you'd have x minus log base 6 of 5. Then you want to set each piece equal to 0. So we'd either say x equals 0 or x minus log base 6 of 5 equals 0. Then you would have x equals log base 6 of 5. So in this case, we would have two solutions. When you enter this into WebAssign, make sure that you enter one solution, comma, the second solution. Again, this would be an exact solution, and you would probably want to type it in the calculator to get the approximate solution. The last part of this that we're going to look at is what's called quadratic form. So what you kind of look at here is that this is really double of that, which is really no different than saying x squared minus 2x minus 8 equals 0. So you can factor a quadratic like this, and you would say x minus 4x plus 2 equals 0. Then you would set each piece equal to 0. So then you would get x equals 4 and x equals a negative 2. Now, when you're looking at this though, we're dealing with not just x's, but really it's e to the x. So you can think of it as e to the x squared minus 2 e to the x minus 8 equals 0. So you factor it kind of the same way. We have e to the x minus 4 and e to the x plus 2 equals 0. Set each piece equal to 0. So you'd have e to the x equals 4. Solving that, we're going to have the ln of 4 is equal to x. Again, that's an exact solution. On this side, we'd have e to the x equals negative 2, but e to the x will never equal a negative number, so that does not work, and that would be our solution. So that really kind of sums up our exponents, and now we're going to go into solving some log equations. One thing that you have to think about with logs, in order to solve a log, you have to change it to an exponential. So if you think of ln, remember ln is really log base e. So we rewrite this as an exponential. So it would be e to the 3.6 equals 6x. Remember, a log is a fancy way to write an exponent. So really this log is the exponent. Solve that for x by dividing by 6. We get x equals e to the 3.6 over 6. Again, this is an exact solution. Type it in the calculator to get the approximate solution. On the other side, just like before, we had to isolate the exponential. This time you have to isolate the log. So we'd have negative 4 ln of x equals 5. then we have ln of x would equal 5 over negative 4. Now again, to solve this, we have to change it to an exponential. So it would be e to the negative 5/4 equals x. One thing that you have to check on these is you should always check your solutions, because you can never have a negative number or take the log of a negative number. So it is important to check that. Again, if you look at this, e to a power will never be a negative, so that would work. This would be an exact solution. Again, to get the approximate, plug it in your calculator. What if we have something like this? Well, again, you have to isolate the log. So we're going to divide both sides by 6. Log base 3 of 0.3x equals 13 over 6. Again, rewrite as an exponential. 3 to the 13 over 6 equals 0.3x, and divide by 0.3. Again, make sure you are checking your solutions, because again, you cannot take the log of a negative number. But if you look at what you have here, this would not be a negative solution. Again, you'll want to type that in the calculator to get the approximate solution. The next one here is requiring you to use some of the properties. So when you see subtraction, you can change it to division. So this would be the ln of x over x plus 1 equals 2. Now you can do what we did on the previous ones. Change it to exponential. So then this would be e to the 2 equals x over x plus 1. Now to solve, you're going to multiply both sides by x plus 1. That allows you to get rid of that denominator. So we'd have e squared times x plus e squared equals x. Again, move everything with the x on one side. So we'd have e squared x minus x equals a negative e squared. Factor out that x. So we'd have x times e squared minus 1 equals negative e squared. Divide both sides by e squared minus 1. Now, if you're looking at here, again, you're needing to check your solution. Well, negative e squared over e squared minus 1 is going to give you a negative number. So in this case, you would have no solution. So please make sure, again, that you are checking your answers. Again, this is one with properties. So again, if you see division, you're going to change it to, or sorry, subtraction, you're going to change to division. So we'd have x minus 8 over x plus 8 equals the ln of x plus 9. The nice thing here is if your logs are the same on both sides and you only have one of them on both sides, you can drop the logs and set the arguments equal. Then what you're going to do is multiply both sides by x plus 8. These will cancel. You'd be left with x squared plus 17x plus 72 equals x minus 8. Move everything around. So we'd have x squared and then plus 16x. We are going to add. So that's going to give me plus 80 equals 0. Now again, you can factor this, or you can do quadratic formula, whatever you want to do. So if I did quadratic formula, I would say x equals negative b plus or minus the square root. We'd have b squared minus 4ac all over 2a. Whoops, but our a is 1. So just 2. So if you do 16 squared, I don't have my calculator with me. So 6 times 6, 36. That gives me a 96 and a 16. So we would have 256 minus, and this would be a 240, which that's going to give me a 16. So I'd have negative 16 plus or minus the square root of 16 all over 2. Well, the square root of 16 we know is 4. So we have negative 16 plus or minus 4 over 2. Negative 16 plus 4 is a negative 12. Divided by 2 is a negative 6. So we'd have x equals negative 6. Negative 16 minus 4 is a negative 20. Negative 20 divided by 2 is a negative 10. Well, if we go back up and look, if you plug in negative 6, we're going to get a negative number in here. That one's not going to work. If you plug in negative 10, it's not going to work. So in this case, we did a lot of work and we have no solution. If you have any questions, please make sure that you're contacting me. I know this is a long video, but I was trying to go through as many examples as I could. Have a great Wednesday.